Hi, welcome to FlowFest 2022. My name is Greg Harley, and I'm a solutions architect here at Flowable. I've been working in BPMN for about, I don't know, since about 2006, where I started with a company called Lombardi, which became IBM BPM. And I've been working with Flowable since about 2013, where I started building out applications using the predecessor activity. I'm based out of the United States, so it's early morning here in Austin, Texas. Today we're going to be talking about how to survive at scale. This particular subject is, pretty broad. So I was trying to nail it down to something a little bit smaller. And so what we're really going to talk about today, not so much performance, there's some other really cool presentations on that, but about managing your data, managing your environment so that you're able to maintain good performance going forward with a significant application. So that's what we're going to talk about. We're going to talk about the data. We're going to go through a couple of case studies. We're going to talk about the things we need to consider when we're looking at our data implications, and then what we can do within Flowable to mitigate, any of the issues that may arise, how to manage what data we've got, and ultimately, then we're going to talk about housekeeping or data truncation. During this session, you can enter any questions in a chat window at the bottom of the screen, and Matthias will coordinate those for our question and answer session at the end. And I believe there's also the ability to chat with other people watching the session in the view window as well. So let's get started. So when I first started thinking about this subject, I was looking for some quotes that would capture sort of my feeling. These days we have abundance of data everywhere. Everything we do, our toasters talk to the internet, everything talks to the internet, everything collects data. In fact, by 2025, the amount of data collected globally per day is expected to be in excess of 400 exabytes. Now, an exabyte is 1,000 bytes to the power of 6, so that's quite a lot of data. But in many ways, we as process professionals, as automation professionals, are in that same business. A lot of what we do is about collecting data. A lot of what we do is about using that data to improve the processes that we manage. And that's what this is all about. Okay, BPMN, CMMN are about data collection. Right? We take the data, we measure it, we find key performance indicators that will represent the health of our process, the health of our case. We monitor those indicators to ensure that they're within certain bounds. We use the data to identify issues that may be occurring. For example, we may be starting to get close to our service level agreement limits. And so we can use that data to not only within the process or the case act, but also to review and manage the designs of these models going forward, based on the key indicators and the measurements that we're taking. All right. So BPMN and CMMN, from the very moment, from their very inception, was about management of the process. It's a continuous cycle of measurement, improvement, measure, improve, and go on. So in many ways, data is an integral part of what we do. And when you buy into the whole, process management philosophy, that's part of what you should be considering. But that's not all the data that we collect. One of the very first systems I ever built with what was then activity was about compliance. It was about ensuring that that the particular lender was meeting their required regulatory compliance requirements, and in fact they had been in some sort of trouble and had to prove that they were meeting those things. And the only way they found that they could do that was by implementing a Flowable solution to track the important data through the process. But no matter what industry we're in, and that was the financial industry, but no matter what industry we're in, where all of our businesses are bound by some sort of government or governing body for compliance. Sarbanes-Oxley was all about lending practices. We may be in manufacturing, so we have to work with the EPA. GDPR tells us what personal identifiable information, always have trouble with that, can be kept, where it can be kept, and how long it can be kept. So there's compliance requirements everywhere, and this is also part of what the data that we would collect within any process or case. Then, especially here in the United States, one that we have to think about is litigation. While there may be some regulatory requirements, it's important to ensure that we can prove that we're behaving fairly and correctly, so that if we are litigated against, we can defend ourselves. And then finally, there's the new kid on the block, the latest entry data that we collect, and that's the fodder for data scientists. All right, data scientists will collect everything that we can give them, and they will then throw that into a data lake, start playing around with analytics tools, and try to do things like finding different industry trends, identifying waste within our processes. They may be trying to look to see if certain things within the economy may have impacted the types of products that are being requested from our company, or the limits or the extent that those products are being exercised. It may change the approvals, the number of approvals that are being or denials that are being taken within our process. And so the analysts will try to bind this to external information to try to understand, or to try to take advantage of what we know about our process, what we know about our business, and what we know about the rest of the world. All right, so in reality here, data presents us with a competitive advantage. So it's something that's very important for us. But with all this data, there can lead to bloat within our systems. All right, and what we find, and what I've seen many times, is in the rush to build out a solution, we may not consider what we're doing with that data. We're not considering what data we're collecting, where we're putting it, right? What are we going to do with it in the medium to long term? What do we actually need? What data do we really need versus what data are we keeping? And in some cases, we have to ask ourselves, do we really care? Typical sort of straight through processing solution where you're doing service orchestration and instances last, some seconds. You may not even care about holding on to any historical data. You're not doing any measurement. You're not using it for analytical purposes. You're using it for orchestration. So leaving your settings at the default makes absolutely no sense, and all that does is leads to potential runtime issues and performance issues. So we're going to have a look at a couple of use cases. Literally both of these cases are issues I've dealt with different customers in the last 3 months. So this is not unusual, and it really is one of the reasons why I thought this was a good topic to cover, because it is something that we see pretty regularly. So the first case is a large American telecommunications company. They had a relatively new application added to their others that had been in production for about 6 months. They had about 10 million case instances in their history. All right, that's not that many, but that's what they had in their history. They had over 100 million variable records in their history tables. And what they found was they went to create new indices, and they found this when they were actually doing an upgrade to the Flowable engine, and we were starting to create new indices on one of the existing tables, and the database would hang creating the index. We're able to get them through the issue. We were able to create the index offline, got the upgrade working, but the root problem remained that they hadn't adequately sized their database for the amount of data that they were collecting. They had 6 months of data. They had over 100 million variable records. And when we started talking about, okay, so how long do you need this particular data for? What sort of data are you saving? What sort of data retention do you need? And the answer came back, well, they needed a duration of about 2 weeks. They weren't doing at that time any analytics, but they did require their processes were lasting a few days, so they did require some history, and they needed it for they were also using that history for analysts to look up previous instances and so forth. So they had 6 months. They needed 2 weeks. They probably sized their system with the expectation that they'd be keeping 2 weeks worth of data, but they hadn't set it up to keep 2 weeks worth of data, and they were continuing to collect data. It was continuing to cause problems to the database, and obviously needed to be addressed. So that's the first case that was literally 2 months ago. So the second case was a large US insurance company. All right, application it had been running great, been in production for 9 months, no problems, everything's running terrific. They did have a basic data management strategy in place. They were deleting all their records after 6 months, which is what they had determined was going to be adequate for them. They had about 300 million instances in their history database, but all of a sudden, their system database started reporting deadlocks on the byte array table. And they couldn't really understand why. We couldn't understand why, and started looking inside. And we found that they had over 90 million records in their byte array table. And those records had no reference anywhere. What they didn't realize was that the byte array table held binary variables rather than the variables going into the variable table or the history variable table. Those variables were held in the byte array table with a reference from the variables table. They had cleaned up the variables table, but there was no foreign key, so there's nothing to tell them that data was elsewhere. And so they didn't realize that they needed to clean this up as well. And so what that ended up doing was causing, once again, the database to have performance issues. So data is a real problem, right? And you've got to manage it. It can impact your system if you don't appropriately size things. So where is all this data? This is a pretty simple question, right? Obviously, the database, the main system database, it contains your models, right? It contains your deployments. It contains your data objects. So anyone who saw the previous presentation was learning all about data objects. It contains all of your runtime data, and mainly it contains historical data. That's where the volume is. That's where everybody, where all of the sort of the good news but the bad news comes from. So it is your historical data. We also have Elasticsearch. Elasticsearch is essentially based on Lucene. It's a file system based document store. And the Elasticsearch has almost all of the same data that's in the databases. It doesn't have data objects, doesn't have models and deployments, but it includes your runtime data. It includes historical data, but it also includes metrics such as your CPU, the performance of your job executors, database connections, a slew of other information like that that's used for some of our canned reports, and also that can be used to monitor the health of the whole environment. For those of you who sort of have some history, the Elasticsearch was introduced not all that long ago, because it allows you to do analytics offline without making queries that impact the operation of the runtime environment by touching the historical tables. But we still have to maintain the historical tables, because there are many who have come along with us for a while, and they're running reports against those tables. So we now have some duplication across both databases and Elasticsearch. And finally, we've got data in a content store that may be on a file system. So something really worth considering. That may be in your it may be in some sort of a content repository that you're using. It may be in the cloud on, say, an S3, AWS S3 environment, but it's still somewhere. And especially with cases that maintain documents, you're doing sort of loan management, underwriting, things like that, where documents are a big part of it. Contracts, it is not an insignificant amount of data that you have to maintain and manage, and it's important, right? If anything, that is the contracts and signed documents are the lifeblood of your business. The process is really all about enriching that and ensuring those things get completed. So that's really important data as well. So what do we have to consider when we're coming up with a strategy? What we really need to consider is, I've tried to put this in some level of order of priority. Okay, obviously, when we're capturing, collecting data, our legal and regulatory requirements are the top consideration. So what must we keep in order to be able to satisfy our legal requirements and the requirements of the various regulators that we are bound to? After that, we really need to, and this is something that people tend to overlook in the heat of the battle more than anything else. If anything, people take too little time at the start of their application development process to understand what the indicators of the process are going to be. What are the measures that are going to tell you if you're healthy? What are the measures that are going to tell you if you've got some sort of a bottleneck somewhere? What are the measures that are going to tell you if you've got issues within your process itself? Sometimes these things are as simple as service level agreements or response times. Sometimes they're more complex and come down to how certain decisions are made, whether they're made through a decision tree or something like that. So the next thing after legal obligations is take the time to work out what your KPIs are, your process measures are, and ensure that you collect those. In many ways, excuse me, in many ways, this is key to your ability to continuously improve your process. Then you may have, if you have human involvement, they may want to use past instances to reference when they're doing their work. When you have knowledge workers, there is often the case where you have to do ad hoc work or non-required work, and they may want to use past cases to determine how to treat a particular scenario. So you want to keep look up information for reference purposes. Then there's analytics. Obviously, the data scientists will tell you that's hugely important. This is where a lot of data can be generated, but then you have to work out how much you really need for that and what you really need for that. And finally, one of the things that's come up fairly recently, and again, it is a real data hog, is training in AI. You may want to replace a decision service with a call out to an AI to give you a better decision result, so that you can, do auto throughput of a higher percentage of particular cases. And in order to do that, you have to train an AI. To train an AI, you need data. So what data do you need to train that AI? And you need to collect all that. And sometimes you have to also consider things like PII. You may have a requirement within your company or country to be able to delete PII that is bound to a particular case, process, or instance, somehow document. So it's important to ensure you have the mechanisms to be able to do that, and isolate that and do that. Okay, so how do we do this? How do we control what Flowable puts away, and how do we control what we save? Well, there's a number of ways that we can do that within Flowable, and some of these are new and some of these are pretty exciting. Some of these have been around for a long time. All right, so the one that we're all pretty familiar with is the history level set in your application properties. You can set that to one of a number of different levels. We'll talk about those levels in the next slide. And traditionally, we've had history levels of none. We've had history levels of audit and full, basically. Those are the activity, audit, and full. Those have been the ones that we've had in the past. All right. Excuse me. What's important is to consider the default history level. Out of the box, the default history level is audit. That is going to save quite a lot of information. All right, and again, I'll talk about what is saved in the next slide. If you've got a straight-through process, or you're doing service orchestration, you almost certainly don't need an audit history level. So consider setting that to something less chatty, that collects less data. There's also a new feature within the product for that allows you to set history levels at the root case or process. This can then override the default history level. This starts getting really interesting because it lets us set the default history level to something much lower, because at a particular case or a particular process, we can say we actually want to save more history, right, for this particular segment of the process, and we can actually define what that more history is. So it gives us a lot more tunability around saving that, the history that we save. Now we start getting to even more interesting things. As of, I think it was 3.11, we can now define, or we can declare which data, which variables we wish to save. So no longer do we say at audit or activity or full level of history, we basically saving all variables, including all of the derived variables or variables that we're just carrying around so that we can make decisions on them, even though they really don't represent anything in the overall process or in terms of the case. We can now declare what variables we're actually going to save, what variables get put into Elasticsearch, and that we can query on later. So that's a new feature that is really, really useful. It allows us to be a lot more flexible and focused on the data that we're putting away. And that's set, as I say, in the case or the process properties panel. And then finally, this one has actually been around forever. There's an include in history checkbox on every service task, on every user task, and basically it tells you, do I include this this particular task, whether it's a service task or a user task, do I include this transaction, this activity in the history? And you get to choose that. I can't remember the last time I reviewed a model where somebody actually set or started excluding tasks. Yet, you know, for example, a service task, nobody really needs, there's very little need to capture data from a service task unless that service task does something like change a key indicator or something that you need to collect. So generally service tasks are about enrichment. They're going to collect more information based on stuff you already have, but rarely do I see people actually explicitly managing the include in history checkbox within each task, but really important. So the history levels. None, all right, obvious. There are scenarios, I mentioned one earlier with straight through processing, where none may make perfect sense. You don't really care, you're just running this thing through, and you don't want to burden the system with capturing a bunch of history that you don't care about. Then we come with a couple of new levels that have been available since 3.11, and what that is history on the instance level. All right, so the only data we store is at the instance boundaries. Okay, that's a case instance or a process instance. Okay, so we'll collect the data at the start, we'll collect the data at the end, we'll keep the timestamps. Yeah, think about this in a called activity or something like of that nature. We're basically keeping the timestamps surrounding the called activity. And both instance and task work with the declared variables list that I mentioned earlier. So you can say at these boundaries, right? At these boundaries, you collect the following data and nothing more. So that gives you a really fine level control over what data you're collecting and the boundaries or the definition of when you're collecting it. So you're not getting stuff that you don't really need. Task, right, collects a little more data. These levels are listed, as you can probably tell, in levels of collecting more and more as we go down the list. Task basically stores is the same as instance, but it also adds user tasks, not service tasks, but user tasks. So and it is new since 3.11, and it also acts in conjunction with the declared variables. So you can define the data that you wish to at user task level rather than just on the instance as in the previous. Activity's been around forever. This is one of the standard history levels we've had for a while, and that's basically the same as task, but it's service tasks as well. So we've got user tasks, service tasks, instance boundaries. We're starting to collect a lot of data here. Now, a note, activity, audit, and full levels don't work with the declared variables. Only the two two new history levels, instance and task, will work with the declared variables. So activity, starting to collect a lot of data here. It's the same, pretty much the same as task, but it, as I said, includes all activities such as service tasks, gateways, and those sorts of things. Audit, this is the default. This is what comes out of the box. And all too often, this is what we see people sitting with, you know, even through to production without really thinking about it. And that starts collecting a lot more information. It includes, you know, things like entity links, references to other processes and child processes, and variable entities, and things of that nature. It includes identity links. All right. So, you know, who's involved? You know, the owner, the assignee, who's the participant. If it's a task that's assigned to a group, who are the candidates? All right, so you're now also starting to save identity links. Sometimes really important. Sometimes, you know, it's really important to have those identity links. And in that case, that's a perfect scenario to have the history level set at the process level versus at the default level, because you can then determine when you're going to collect this data. And full just collects a whole bunch of data. I mean, it adds to all of the other stuff. It adds any changes to your variables. All right, so any changes to a variable throughout the process, whether that be through services. It keeps a hierarchy of the variables and the parent variables and references. So it's just a lot of data. So there's a few other things we can do. We can use explicit audit events. Again, these are relatively new and, you know, really useful, because what they allow you to do, excuse me, is declare declare a custom history event. Essentially, it goes into the audit log. It's a little bit different to a regular history event, because while it gets collected and saved away, it also is available for viewing within the work interface. So you can actually see audit events and the messages that are tied to audit events within the work interface. So it has a double meaning in terms of it collects specific data, but it also is can be used as a reference within the work interface to make sure certain things have happened, and that you can see the data that's collected and the data that was set when those events occurred. Audit events are modeled, right? They're actually they're different to regular history events, which are just automatic. Audit events are actually placed into the process model, or into the case model. When you build an audit event, you basically declare where it is in the model. You define a message that goes with it. That's the message that's going to get saved into your work interface, or displayed in your work interface. That's the message that's going to get saved away. But you'll also declare the variables that are assigned to that audit event. And the nice thing about that is those variables can be an evaluation, right? Can be a dual expression. So you can actually calculate data that is saved with this audit event. And that makes analytics later on a whole lot more interesting, because you don't have to do these calculations in your analytics engine. They've been done at the time the data was saved. So it just makes querying a whole lot easier. Audit events also have context, whether that might be a case context, BPMN context, can have custom contexts, and scopes, because you may have some security requirements around these particular audit events. So there's a lot of searchable parameters tied to an audit event, just to make querying it later on a lot easier. So you've got the scope, you've got context, you've got the type, you've got a subtype, a lot of different information. Certainly something that I recommend everybody take a look at. Use transient variables, and this is really about cutting down on passing around junk. You may make a call out to a REST service that returns you a JSON array that's got 3,000 elements in it. Anyone who's called out to Salesforce will pretty much understand this. You've got this huge JSON hierarchy, and you only want 30 of the elements of the 3,000 that are being returned to you, but what are you going to do with it? You put that into a transient variable. You then pass it through a variable initialization step, right, where you extract the piece of that JSON variable that you care about and put it into another structure. So you end up passing around just the pieces of information you care about and throwing away the rest. As soon as you hit the next wait state, that the transient variable goes away. You're not holding on to memory, and it never goes into history. So especially when you're making service calls and you're populating data from external systems, think about whether you need to keep the entire structure around. Think about whether you can actually make use of transient variables. Data management. Use a system of record, all right? System of record, data objects help, right? So it means you can externalize the data, you keep references, you don't pass this stuff around as data within your process. Very rarely is a process system, or should a process system be the actual system of record for your business. You know, almost certainly it's going to be something else. And so don't have duplication within your process system and your system of record, because then you start getting into other issues, such as, you know, which system is correct at any given moment, and it can cause, you know, it can cause issues that way, especially when it comes to auditing and analysis. Audit more than anything else. So if possible, use the system of record. Pass references to that system of record around. Like I say, with data objects, that's automatic. All that gets passed around with a data object is an ID. When you need the data from that data object, it goes and queries it, whether that's from a database table or through a REST interface. But if you're using, you know, for anything else, you know, try to minimize the data you're passing around. Try to pass around IDs, indicators, references that will reference data out of a system of record, so you can pull it when you need it to be able to make decisions within your process. Data truncation, we'll talk about that in a little bit. All right. We're going to talk about it now. In the past, in order for us to be able to delete data that was saved, we had to we only had two options. One was we go and run some database scripts, and you know, we would typically look up the forums. We'd have a look and see those database scripts, that there were recommendations in the forums of what we have to do. We would implement them maybe as a stored procedure, or maybe as you know, on a cron job within the database, or what have you. Maybe tied to a process. You have tied to a process that calls out and executes these scripts as a stored procedure. However you did it, but that was really how you did it. They were painful because, you know, the schema changes every time we do an upgrade. Not every time, but often when we do upgrade, we're going to add indexes. We may add constraints. We may add tables for new features, and so you have to continue to maintain those scripts. And there's also, if you remember the second use case I mentioned, where they had left you know, stray records behind in the byte array table, they had database scripts built. They just didn't realize that they also needed to clean up this other table, and so they left data behind. So that, you know, it's that's kind of how you had to do it, right? Or you could use some custom code. You know, we can query the history service, right? History service query. We then delete, whether that's process or case instances. We can delete those instances, again, using the Java API. We can do that again, so we can build out a service task. It can be tied to a timer event, run fairly regularly. No harm, no foul. Everything will work. Couple of problems with this, though. We have to maintain that. That's on us to maintain. Okay, so that's and as I say, as you go upgrades, or you have to continue to maintain it. And the second thing is that doesn't really delete associated content. It doesn't delete associated content at all. What's associated content? Content items, right? Audit items aren't deleted. Template items. None of these things are actually managed. And so if you if you want to manage those, you have to do that as an extra. You have to do it as well. It doesn't touch Elasticsearch. So you clean up your database, but Elasticsearch is still out there. So you then have to go through and do the same sort of thing for Elasticsearch. So really not a great option. So in 3.11, we introduced housekeeping. Housekeeping does all of this for you. What does it do? It creates a batch. That batch is based on a time window, a set of parameters that determine what you want to delete. Those batches are then broken up into parts or smaller transactions. We call those parts. The parts are then bulked together into a single transaction and then executed sequentially. So when one part completes, the next part is scheduled. When that part completes, the next one is scheduled. No two, we also have some checks in there so that no two housekeeping runs can occur at the same time. Why? Because, you know, if you've got, like one of my scenarios earlier, you've got 6 months worth of data and your housekeeping run, you're running it, say, overnight, and your housekeeping is still running because you've got so much data. The next day, when the next housekeeping run tries to start, you don't want those two things to overlap, right? Because then you're starting looking at the same the same records. So no two housekeeping runs can run together. We do that for you, and we break it up into these small transactions. One of the reasons why we want to, you know, do a small transaction is because, you know, you're basically doing a delete where an instance where an instance ID is in a given set. And some databases, most databases, have a limit to the size of those sets, the size of the SQL. And so you can define the size of the parts you're going to, the size of the parts that you're going to delete in a single transaction. There's other reasons you want to be able to do that, primarily for efficiency purposes. I said parts are deleted sequentially. Again, this is so we don't overload anything. This is so we don't throw, you know, thousands, potentially, if it's a big run, potentially thousands of requests at the database at one time. So we do them sequentially. And parts are handled, these deletes are handled as jobs. They're just the standard history jobs, just like our history storage, so that they make use of the job scheduler engine, just like any other job, and they get prioritized in the same way as any other job as well. So you're still able to work within the tuning parameters that you have for your job scheduler setup, and you're able to manage that. You can limit the number of threads and those sorts of things that way. It works for both case and processes, of course, and it deletes out of the database and Elasticsearch. So you don't have to separate, you know, your Elastic and database history. We will manage the records in both those systems for you. And finally, it's cascaded, right, into sub-processes, sub-cases. So you, once again, you don't have to do that yourself as you previously would have in history. If you're doing your own scripts, we manage it for you. We'll cascade. If we make a call activity, we make a call into a subcase. Those will be picked up and deleted along with our other instances. So how do we set this up? The easiest way is as in your application properties, we have a set of parameters. By default, history cleanup or housekeeping is turned off, is disabled. So you would enable it, right? And at a bare minimum, we should be doing at least this, right? We should enable it. We should set up a cycle. It's a simple cron expression for the cycle. The one on the screen that is I don't know if that's the default or if that's a sample one, but it's basically at 1 a.m. every day. This cycle is going to run. We determine how old the information is, how old the data is that we're going to delete. Here, again, it says 365 days. So if it's more than a year, it's going to delete processes and cases. And then we have the batch size I talked about earlier. Here we're going to do 100 at a time, 100 instances, whether that be cases or processes at a time. We could set that to 10, we could set that to 1,000. It really comes down to what works best for you, and what, keep in mind the load that this puts onto the system. So you need to sort of consider that. And a lot will come down to, if I'm collecting 1 million instances a day, then I probably need to run bigger batches. Okay. Now, some limitations here. It's a blanket policy for cases and processes. It doesn't provide any sort of level of filtering across definitions or anything like that. So it's a very blunt tool. But at the very least, we should be considering using this in all of our systems, so that we don't get to a scenario where we've got too much data. The second one is our on-demand, and this is selectable from the control interface. Within the control interface, we can delete data within a particular date window. We can give the run a name so we can track it for later on. We can determine if we're looking at cases or processes, so we can delete either cases or processes. We can select based on a definition, so we can have a case or a process definition, and we can also add a business key. So that gives us a lot more, focus on the data that we're going to clean up. And why would we need that focus? Well, consider you've got an application that's been running for a long time. You've migrated to a version 2 of that application. It's been running for a while, and you really don't care about anything to do with the previous definition, the previous application definition. You can selectively delete everything about that previous application and move on, and with just the data for your new application. So there's scenarios where you want to do this, and that's one of the scenarios where we'd use an on-demand out of the control interface. The most exciting one, though, is we can now model this, right? We can model this within a process. We can model it to to trigger. Excuse me. We can model this to trigger on a timer event. We can model it to be triggered on a signal from another process. It's completion of some sort of administrative set of tasks, can then go and trigger housekeeping. We can model it any way we like. There is a housekeeping, as of 3.11, there is a housekeeping service task within the palette of a process. That's really cool because it gives us even more flexibility. Not only can we have all of the same sort of properties that we had for the batch, for the on-demand, but we also and we can basically choose our batch size and things like that. But in addition, we can determine, we can define a list of process definitions, so it doesn't have to be a single process definition. So we can actually get more flexibility in what is deleted and when it's deleted. So the housekeeping, modeled housekeeping is really cool. I'm looking at the time. I need to move along, I think. Finally, there's always, just like everything in Flowable, there's always a way to do it in Java. Everything is possible in Java. So you could create your own service implementation to call the history service and delete sequentially using batches, basically the new methods that have been added in order to maintain housekeeping. And there you can again set the batch sizes, set your set your window of that you're interested in, start time, end time. One of the things you can do in Java that you can't really do in modeling is to include or exclude your sub-processes. So that's a little more that you can do there, but in general, the modeling is the way you would go about it. So that's pretty much all I've got. Hopefully this was helpful to somebody. If it wasn't, if you walk away with nothing else, Why do Java programmers need glasses? Because they don't see sharp. Thank you, everyone. Thank you for your attention. If you've got any questions, I think Matthias will sort of go through them now.
Yep, we have a couple questions. Technical team, do we still have any time? I think so, right? Yeah, so let's see. The most popular question I see here is, can we perform housekeeping for active instances? Yeah, this is referring to the fact that we were mainly talking about historical history.
Right. No, housekeeping is only for historical instances. So it directly interacts, it uses the history service, it directly interacts with historical instances. So housekeeping is not a tool for maintaining or managing currently run.
All right, good. Then another question is whether housekeeping is available in the open source version.
Housekeeping is available in the open source version, yeah. Yes.
The Java APIs are there, right?
Now, the Java APIs, that's thanks, Matthias, that's right. The Java APIs are there. You don't, and you can use the default configuration options in the open source in your application properties. What you don't get, obviously, is you can't trigger it. You don't have access to control, so you can't trigger it that way. And the modeler, the open source modeler, does not include the housekeeping service task, so you can't model it. But yes, it is available within the engine as an engine feature within the open source version. So the Java API is there.
Okay. Then there is one more upvoted question. Maybe we can quickly have a look at that, and the remaining ones we may need to answer in the tool directly.
Sure.
How do you scale Flowable work? We currently don't know how to scale with the sessions. Can you use Redis for session storage? So this is not really in relation to the topic of
sure.
history and so on, but more of a
I think that's something we should probably take offline and get a little more detail around it, because Redis being a document store, that's a whole different thing.
Yes. Oh, new questions are coming in. Okay. Yeah, I think in the interest of time, we will try to answer your questions directly in the tool. So just have a look at that. Yes. Now all the questions are pouring in. Well, yeah, but we will try to answer all of them. Okay.
Okay.
Good. Thank you, Greg.
Thank you, Matthias. Thank you, everybody, and enjoy your FlowFest. I'm going to pop on over to the hyperscaling presentation that's coming up. That sounds like it's going to be very cool.